Hello everyone. Today, we'll be discussing an important topic, thermodynamics and its role in fire safety. Our group is Group 2, and these are our members. Fire behavior and temperature. Fire behavior varies, with some burning slowly and evenly and others fiercely and quickly. Temperature indirectly influences fire behavior by influencing fuel moisture content and wind formation. The higher the temperature of the fuel, the easier it is to catch fire. Flashover is a simultaneous ignition of most exposed combustible materials in an enclosed area. It causes thermal decomposition and release of flammable gases. It typically occurs at 500 degrees Celsius or 590 degrees Celsius for ordinary combustibles, with an incident heat flux of 20 kilowatt per square meter. Furniture ignites a fire, which leads to flashover and pyrolysis, releasing flammable gases. These gases ignite when temperatures rise because of the heat emitted by the exposed materials. Ignition temperature is a minimum temperature needed for a substance to initiate or cause combustion. Ignition temperature is the lowest temperature at which a substance can spontaneously ignite in air without the need for an external source of ignition. Ignition temperature is important for fire safety because it helps to prevent explosions. To avoid the risk of explosion, equipment must be kept below the ignition temperature of explosive mixtures. One of the essential characteristics of combustible materials is the auto-ignition temperature, sometimes it called self-ignition temperature. It represents the critical point at which a material reaches a high enough temperature to cause a chemical reaction of combustion. Safety in a variety of environments can be ensured by understanding the auto-ignition temperatures of different substances, allowing necessary precautions to be taken. Several factors can influence changes in auto-ignition temperature, and understanding these factors allows for effective assessment and management of fire hazards. Different substances have different molecular structures and reactivity, and therefore naturally have different self-ignition temperatures. Highly volatile compounds, gasoline and ethanol, have relatively low auto-ignition temperatures and are therefore more likely to spontaneously ignite. Heat transfer mechanisms in fire safety. There are three types of heat transfer mechanisms, which are conduction, convection, and radiation. For conduction, the heat transfer through direct contact with materials is particularly efficient in metals and can lead to structural failure if critical components overheat. Therefore, the safety implication is to use non-combustible or fire-resistant materials to mitigate this risk. Convection involves heat transfer through moving fluids, such as gases. As hot air rises, it can spread heat and potentially ignite distant materials. The safety implication is to implement proper ventilation and utilize tactical ventilation strategies to control airflow and limit the spread of fire. Radiation refers to heat transfer through electromagnetic waves, which can ignite nearby objects without any direct contact. The safety implication is to use radiant barriers to reflect heat and protect structures from ignition. That's all from us. Thank you for watching and learning with us today.